Hi guys, Shouvik here. Welcome back to YouTube channel. So today we solve another question from Leetcode itself. So let's get started. Yes. So today we have the question that is tagged as an easy and it's a super easy problem. So we just need few minutes to sort it out. Yeah. So what they have given? So they have given a max. So they basically looking for maximum difference between even and odd frequency one. So you are given a string S consisting of lowercase English letter, and your task is to find the maximum difference diff between frequency of A1 and frequency of A2, between the frequency of characters A1 and A2 in the strings, such that A1 has odd frequency in the strings and A2 has an even frequency in the strings. And finally we have to return this maximum difference. So we basically have to look for, so if we can quickly go to our OneNote. So what they have given to us, so we have a string S. So we have a string S of holding some values A, B, C, D, E, this, right? So this we have it. Now what we are looking for, now they are basically looking for the answer. The answer is odd. Let's suppose a particular numbers, the max odd count, max odd times a particular number, let's suppose occurs odd times. Then let's suppose two characters has occurred odd times. Two characters, let's suppose two characters, two or more characters has occurred odd times, and we need to take the max things is not there. Max things I just incorporate. So we basically need odd frequency of any character minus even frequency of any character. So we need this gap. What is this gap? So this gap should be maximized. So that we need. So this gap should be maximized. So how we can get it? So here you can see in the example test cases also, S consists of only lowercase English letter on the constant, and S contains at least one characters with odd frequency and one characters with even frequency. So this is bare minimum. So we definitely have at least one characters with odd frequency and at least one characters to even frequency to form our answer. So on this example test case, you can see A occurs 5 times, so that is of odd frequency, and B occurs even times, that is of 2 times. So 5 minus 2 is 3. And C is also occurred 1 times, right, which is odd. But if we do 1 minus 2, so in odd frequency, rather considering A, if we considered C, then C's frequency, C is also odd frequency, then our odd frequency is 1 and even frequency is 2. Then 1 minus 2 is minus 1. But we got 3 as an answer. So which one is greater? Between minus 1 and 3, 3 is greater. So we took 3. On this example test case, you can see A occurred 3 times, C occurred 2 times. And if we do the delta of 3 minus 2, that is the maximum. So that is the maximum. So now go to our OneNote. Let's go again to our OneNote. So we need these things to be higher, these things to be on the higher node, these things to be on the higher node. So who is actually contributing to this? So our answer is actually, what is the problem here? So our answer is actually max of odd minus even, right? So this we need. So odd frequency and even frequency. So these things we need to bump up. So on very naked eyes, what actually we have to basically, so can we compute our odd to be independent? So if I can try to distribute it. Okay, there is a power cut, I think, from my side. Let me see if streaming is happening. Okay, streaming is happening, although what has stopped, this has stopped, but streaming is going on. Okay, fine. So now if I'm might not be able to use the space test to write it, I can use that only to basically do my job. Or I can just, let me just turn on my flashlight quickly. Give me 1 minute, guys. I'm just coming. Is this? I am back. So still recording, right? So just neglect the backgrounds of, because there is a power cut at my place and the backup is also not working. So yeah, so what actually happening? So to basically maintain the formula, what we need this odd frequency to be maximized. Agree, this odd frequency should be maximized if there are multiple odd frequencies that we saw in our sample example discuss. One odd frequency, one character's odd frequency is 5, one character's odd frequency is 1. So which one we have to consider? So these things we definitely need max. So this particular block, so odd frequency we definitely need max, and on even frequency, this particular block we need min, so that the gap between them is maximized, because on the first characters from where we are basically negate, on that particular characters we are taking max, and the characters which we are negate, on that we are taking min. So right, on odd frequency, if there are multiple odd frequency, we need to take the maximum of those. If there are multiple even frequency characters, then we have to take the minimum of those. And like this, then my negations is always going to be maximized. Yes. That is by default going to be maximized. Yes, that's exact things we just have to write in our code iterations terms. So here you can see I took a default dictionary and I am iterating to store all the characters frequency. And now I have choose odd max. That is for odd I need the max, and for even I need the min. So odd max I have initialized with 0, and even min I have initialized with 100 ones, because s length is as big as 100 only. So now I am iterating for each in my default dict. If my dd of each is and 1, so that means it's an odd frequency. Then for odd frequency, what we have to do? We have to maximize what is the odd max currently have at 2 dd of each. Else it is a min, it is an even. So for even we have to do its minimized to even min 2 dd of each, and finally we can return our odd max minus even min. That is our answer, because on that case the delta should be more. We are taking the maximum on odd side and minimum from my even side, right? A1 is the odd frequency in the strings and A2 is the even frequency of the string, and return the maximum difference. Or more specifically, if they have already mentioned A1 has the maximum of the odd frequency and A2 is the minimum of the even frequency, then the problem is altogether solved there. So that's actually the hidden logic we have to find. Then the difference is by default going to be maximized, because there is very standard maths. So now we can quickly discuss the time complexity. So the time complexity, tell me, we are iterating a big of n for sure on initial go, and second loop is going to be on dictionary. How many keys we have at in dictionary? That is of 26. The second iteration is of big of 26. And on space perspective and on space complexity, tell me guys, on space perspective it is bound to be of big of 26 only, because the dictionary can have at max of 26 characters from a to small z. Yes. And you can see like it is bound to be like it is 3 milliseconds, maybe some submissions took 0 milliseconds. That is, but let's not consider that, because if you are delta of time complexity is kind of a milliseconds only, like in kinds of 1 to 2 to 3 milliseconds gap, like within 10 milliseconds gap, then that is bound to be the most optimized one. And yeah, so that is for sure going to be the most optimized one. And space perspective, you can see like it is of 99, like 100% faster than all over the submissions. And also there is a delta of 0.1 in beyond. So that is also like Leetcode. That is going to be vary with submission to submission. Maybe at one more submissions is going to provide an AC for this, like 0 millisecond for sure. Yes guys, so that is bound to be the most optimized time and space complexity that I am able to think of, and it is for sure the most optimized time and space complexity that you can achieve for this particular promise. And if you guys are able to understand till this point, I guess then you guys are already doing so. Please do subscribe to our channel, and please share the videos to your friend circle who are also preparing for top product based company and brushing up their DSS skills. And please turn on the notifications so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow at the end of the video. Bye guys, bye.